Okay, hello everybody. Welcome to the 199th session of the AI Safety Denmark Reading Group. I'm presenting it tonight. I'm Chris Cooper, and we're talking about the ideas of the physicist David Deutsch on artificial intelligence. David Deutsch is a visiting professor of physics at Oxford University. He was a founding member of the Center for Quantum Computation, and that's what he is mostly known for, that he, as a pioneer of quantum computation. His citation for being elected a Fellow of the Royal Society, which I'm showing here, explains that he laid the foundations of quantum theory of computation, and he's made a lot of contributions subsequently. He is known for being an advocate of the multiverse interpretation of quantum mechanics. He champions Karl Popper, the philosopher of science, and he applies Popper's ideas very strongly in, as we'll see throughout this paper. And David Deutsch is also known for developing a personal theory of physics, or organizing principle of physics, called constructor theory, which apparently seeks to express all fundamental scientific theories in terms of a dichotomy between possible and impossible physical transformations. And that is all I know about constructor theory. This discussion is centered on a paper written very much at the popular level. It's called Creative Blocks. It appeared in the magazine Eon. I've called it How Close Are We to Creating Artificial Intelligence, because that seems a better title, and it actually appears in the URL of this paper. The paper argues that we've made virtually no progress in developing AGI to date, but nevertheless we shouldn't be downhearted because we may very well be very close to doing so. Now, David Deutsch's key claim is that AGI, general artificial intelligence, must be possible. And he reckons that he is the one who has proved that. He says that everything that the laws of physics require a physical object to do, any physical system, including in particular the human brain, can in principle be emulated in arbitrarily fine detail by some program on a general purpose computer, provided it is given enough time and memory. He says that the first people to guess this and to grapple with its ramifications were Babbage and Lovelace back in the mid-19th century. In the 20th century, Turing, he says, fully understood universality. But, and you may well have thought that he'd actually proved universality, but Deutsch says that it actually remained a guess until the 1980s, when David Deutsch himself proved it using the quantum theory of computation. Now, Turing concluded that a computer program whose repertoire included all the distinctive attributes of the human brain, including feelings, free will, consciousness, and all, could be written. I haven't had time to go back and look at Turing's classic paper of 1950, which we discussed in this group. And I'm not quite sure whether he actually said this or whether he was proposing the famous Turing test as a way of sidestepping these very difficult questions, just giving an operational test, as it were, to replace them. So I shall be going back and looking at that at some point. But I'm sure actually Deutsch probably knows a lot more about what Turing thought than I did. David Deutsch says that this astounding claim of Turing's split the intellectual world into two camps. One insisting that AGI was nonetheless impossible, the other one insisting that it was not only possible, but imminent. And Deutsch says that both were mistaken. The first camp thought that AI is impossible because of the unique properties of the human mind, and that tend to, possibly to be supernatural qualities or ineffable qualities to do with morality and aesthetics, and the religious sense and subjective feeling and so on. This camp failed to understand universality of computing. In other words, that the human brain is a physical object, and therefore all its workings can be simulated on a computer. The second camp thought that AI is possible and imminent. They failed to realize that the functionality of the human brain, stroke mind, is different from all other computer functionalities. Deutsch says that the core functionality required for AI is creativity, specifically creativity in producing new explanations. Now, the concept of explanation is central to Deutsch's thinking. It has to be contrasted with the mere discovery of correlations, or even the mere production of successful predictions. I say the mere production, obviously that's a big thing, but even that isn't quite the same as explaining in Deutsch's view. It's pretty much synonymous with successful theory, whatever that means. And that, of course, does include successful predictions. Anyway, explanation is very much a key term for Deutsch. Deutsch contrasts programming of a computer to do something very simple, like converting temperatures from centigrade to Fahrenheit. He contrasts that with programming an AGI to address a problem in physics, such as the nature of dark matter. The temperature conversion could be done with a lookup table, or it could be done by means of an explicit calculation. And he seems to regard current AI achievements to date as similar in kind to this. Sorry, I'm throwing up extraneous. Excuse me. Onwards. So with regard to creating a new physical theory, he says, suppose you were somehow to give the AGI's programmers a list of explanations of dark matter that would be acceptable outputs of the program. If the program did output one of those explanations later, none of those explanations would be new. You would already have created them yourself in order to write the specification. Okay, I don't think anybody would argue that that wouldn't be too impressive. He says we need an AGI algorithm with the right functionality. In other words, able to create theories that does not involve first making new discoveries in physics and hiding them in the program. He wanted to do something that we can't do in advance. Researchers have discussed tests of AGI, but these give no clue as to how the AGI is to be implemented. The Turing test, for example, gives no clue as to how it can be passed. And he mentions in this context evolutionary algorithms as one technique that cannot succeed. I don't know how the unfortunate lay person who's reading this article is supposed to cope with the idea of evolutionary algorithms, because he doesn't explain much. But okay, obviously, as I'm sure practically everybody here knows, evolutionary algorithms involve producing some trial AGI programs as test candidates. You judge their success, you select the most successful, you make copies of the most successful ones with slight random variations. You then test those, select the most successful of them, and you repeat the process for many generations, and you accumulate lots of small improvements to get an improved algorithm. And that's, of course, a technique which is used to develop improved algorithms now, narrow AI algorithms. Deutsch says that the Turing test cannot itself be automated without first knowing how to write an AGI program, since the, quote, judges of a program need to have the target ability themselves. In other words, here the judges are the parts of the overall automated procedure that assess the success of the candidate programs. They are the equivalents of human judges in an ordinary Turing test. So he's saying a Turing test might work because human judges know how to judge human behavior. An automated version would also need to be able to judge that, and you couldn't do that without essentially having written your AGI program in advance. You've got to have the ability that you're supposedly testing. He says that AGI cannot possibly be defined purely behaviorally, because in the classic brain in a vat thought experiment, the brain, when temporarily disconnected from its input and output channels, is thinking, feeling, creating explanations. It has all the cognitive attributes of an AGI. So the relevant attributes of an AGI do not consist only of the relationships between inputs and outputs. So you can't judge an AGI by its behavior, because you could cut off all its means of behavior and it would still be a functioning AGI. The upshot of all this is that unlike any functionality that has ever been programmed to date, this one can be achieved neither by a specification nor by a test of the outputs. That's a rather dense conclusion, and very arguable. I'm sure I'll have a lot to say about it. What is needed is nothing less than a breakthrough in philosophy, a new epistemological theory of knowledge, that explains how brains create explanatory knowledge. And this theory will have to define in principle, without ever running them as programs, which algorithms possess that functionality and which do not. So in some way, we've got to be able to create these algorithms and know that they can do the job in advance of running them as programs and getting them to do that job. And as I say, as you will have gathered from my tone, it's not clear to me that this is so. But I'm sure people here will have lots of opinions about that. Now, the prevailing misconception in AI, he says, AI research, is that by assuming that the future will be like the past, one can, quote, derive or extrapolate or generalize, all these things in snare quotes, that one can derive these theories from repeated experiences by an alleged process called induction. But that is impossible. His inspiration throughout this work is Karl Popper, as I mentioned right at the beginning. And Popper stressed the creativity of scientific theorizing and the impossibility of any simple method of extrapolation of the future from the past. Deutsch gives the example of the calendar, a very simple, obvious one, but actually I think is extremely relevant. He says that I remember observing on thousands of consecutive occasions that on calendars, the first 2 digits of the year were 19. I never observed a single exception until one day they started being 20. I wasn't surprised. Not only was I not surprised, I fully expected that there would be an interval of 17,000 years until 19 appears in that position again, because obviously that'll be the year 19,000, the year's day on 19,000, 17,000 years ahead of the year 2000. So that's a period that neither I nor any other human being had previously experienced even once. So that expectation is not based on, in any simple way, on experience. And I'm just adding the example, because I like it, the experience of turkeys who were fed by the farmer for 364 days in a row, and lacking an adequate theory of the farmer's behavior, the turkeys, being good inductivists, assume that the future will be like the past. And they're surprised when on the 365th day he comes with an axe. Back to Deutsch, he says, it is simply not true that knowledge comes from extrapolating repeated observations. Nor is it true that the future is like the past in any sense that one could detect in advance without already knowing the explanation. Without an explanation, any continuation of any sequence constitutes, quote, the same thing happening again, unquote, under some explanation. So you can say the calendar is always doing the same thing over and over, but according to a rather complicated rule. He says, in regard to how the AGI problem is perceived, this casts thinking as a process of predicting that future patterns of sensory experience will be like past ones. That looks like extrapolation, which computers already do all the time, once they're given a theory of what causes the data. Right, I won't dwell on that, but shoot on. And he says something which I find extremely interesting. In reality, only a tiny component of thinking is about prediction at all, let alone prediction of our sensory experiences. We think about the world, not just the physical world, but also worlds of abstractions, such as right and wrong, beauty and ugliness, the infinite and the infinitesimal, causation, fiction, fears and aspirations, and about thinking itself. And to me, that's sort of very pregnant. Whoops, I'll just go back. I just think it's profound and important to me. It just is a reminder of the richness of thought, and it helps to mark off the field of general AI. This is what a general AI would have to be like, would have to concern itself with, and it's very strongly marked off from that of the narrow AI that we're familiar with. Now he has a jab at Bayesianism, not against the Reverend Thomas himself, and not against Bayesian statistics, but just against making it, the be-all and end-all of AI research. He says that the doctrine of Bayesianism assumes that minds work by assigning probabilities to their ideas and modifying those probabilities in the light of experience as a way of choosing how to act. And that behaviorist input-output model is appropriate for most computer programming other than AGI, but hopeless for AGI. And he says it's ironic that mainstream psychology has largely renounced behaviorism, the simple input-output model, whereas AI research is wedded to it. I'm going to be using a pointer possibly from a lot from now on, because I ran out of time to do the animations. Okay, Jeopardy. The famously it's the IBM. It is IBM, isn't it? Watson program won victories on the US TV quiz show called Jeopardy. Jeopardy with an exclamation mark at the end. And it was very impressive, and it was hailed as, our robot overlords are on the way. Jeopardy, I gather, is pretty much a general knowledge quiz, but you have to also do a bit of ingenious connecting of the question you're asked to the answer that's wanted. He says, playing Jeopardy, like every one of the computational functionalities at which we rightly marvel today, is firmly among the functionalities that can be specified in the standard behaviorist way that I described above. No Jeopardy answer will ever be published in a journal of new discoveries. So this is nothing like scientific discovery. There's now a long stretch of misconceptions which he attacks. Another hopeless approach to AGI is to start from existing knowledge of how to program specific tasks, such as playing chess, performing statistical analysis, or searching databases, and then to try to improve those programs in the hope that this will somehow generate AGI as a side effect, as happened to Skynet in the Terminator films. Skynet was a global defense network which just got so big that one day it just woke up, became self-aware, and then started carrying out its evil plans for the human race. And he says that a similar misconception, the whole misconception that increasing quantity will turn into a change in quality, this kind of misconception informs these ideas, that AGI is merely an emergent property of complexity, or that increased computer power will bring forth AGI. He says that a similar misconception is that the unique abilities of the brain are due to its massive parallelism, or to its specific neuronal architecture. And he says that these violate computational universality. In other words, anything that can be done by means of these special properties mentioned here, that can be achieved with them, can also be achieved by any, can be simulated by any computer, any Turing machine, I suppose. I have to speak carefully because I'm not quite sure what's a Turing machine or what's a quantum Turing machine or what, yeah. But they can be simulated by any computer, by other computers. This argument seems suspect to me, just because I can imagine somebody producing a practical computer design and it being criticized on the grounds that you don't need this practical computer design because it could be simulated by a Turing machine. So I'm not quite sure of the validity of this. Anyway, he ends with a nice, he doesn't end, he goes on quite a bit, but he says at this point that expecting to create an AGI without first understanding in detail how it works is like expecting skyscrapers to learn to fly if we build them tall enough. A frequent phrase, often one that's attracted me until I read Deutsch, was anything we don't yet know how to program is called human intelligence. We just apply the term human intelligence to the gaps between what we can program. But what he is saying is, on the contrary, that when we achieve AI, its intelligence will, like human intelligence, be different in kind from other computer functionalities. It won't just be that that we've programmed. No, I won't finish that thought. I'll move on. I apologize once again for giving you rather crowded slides. They were supposed to build up in a nice, smooth way, but as I say, I ran out of time. He wants to insist that the mind is not metaphorically a computer, it is literally a computer. He quotes John Searle. John Searle is he, of course, of the Chinese room argument, and we see him here in his Chinese room, sitting in his room, getting inputs in Chinese, looking in his rule book and shoving out outputs in Chinese, perfect Chinese, even though he doesn't understand a word of Chinese himself. However, this is strictly irrelevant and it's just there because I like the pick. Searle here is making the point that the mind has often been modeled on the technology of the day, whether it was clockwork or hydraulics or steam engines or the electric telegraph. And he says that nowadays we are modeling a picture of the mind on computers because computers are the latest and coolest technology that we know about. But Deutsch says, Deutsch says, no, it's not a metaphor. The universality of computation follows from the known laws of physics, his particular contribution of the 1980s. So there. Here's yet another, another claim that he combats. Roger Penrose, the mathematician, is one of those who has suggested that the brain uses quantum computation or even something beyond that. That this explains the failure to create AGI on existing computers. But Deutsch, who ought to know since he founded quantum computing, or is a founder of quantum computing, says, along with most researchers in his field, that they disagree that this is a plausible source of the human brain's unique functionality. And yet another misconception is that existing software is already intelligent in a sort of primitive way, as are animals in a primitive way, and that we, because of our anthropocentric humanity, we don't recognize that it's continuity with our own intelligence. And as part of that, another misconception is to put great weight on self-awareness. And Deutsch says self-awareness in the behavioral sense, for example, to pass the mirror test of being able to use a mirror to infer facts about itself. You know, chimps and apes and monkeys can look in mirrors and notice that experimenters have put something on their forehead or something like that, and they'll immediately brush it off. This is a fairly useless ability, as well as a trivial one, he says, at least it is as far as robots and AI systems are concerned. It's true that AGIs will be capable of self-awareness, but that is because they will be general intelligences capable of awareness of every kind of deep and subtle thing, including their own selves. Now, self-awareness is closely linked with consciousness. I hope everybody's watching the red dot, which I wiggle around to try and tell you which bit of the screen I'm looking at. Consciousness has a huge range of meanings. At one end of the scale, there's the philosophical problem of the nature of subjective sensations, or qualia, which is intimately connected with the problem of AGI. So Deutsch does attach great importance to this. I think I said last week in our discussion that I can't remember whether I said I was dreading having to talk about qualia or whether I was glad I wouldn't have to. As it turns out, he says nothing about it really, except that it is the problem of subjective sensations are intimately connected with the problem of AGI, but he has nothing more to say about it really. Still talking about the concept of consciousness, he says that at the other end of the spectrum, consciousness is merely that which we lose when we are put under general anesthetic. That's when we're disconnected from sensations for a while. Many animals certainly have that. He attributes no great importance to it. Now, a key, absolutely key assertion of his, AGIs will be people. That they are people has been implicit in the very concept from the outset. if there were a program that lacked even a single cognitive ability that is characteristic of people, then by definition it would not qualify as an AGI. And you should remember that Deutsch has a very wide conception of what is a cognitive ability. Earlier in this paper, he described experiencing boredom as a cognitive task. Now, he makes, I've just imported a sentence defining his idea of personhood from his book, The Beginning of Infinity, strongly recommended. But I brought in this sentence from there where he says, people, whom I shall henceforward define as entities that can create explanatory knowledge. And in this article that we're discussing here, that definition crops up and is asserted as a fact. The fact that the ability to create new explanations is the unique, morally and intellectually significant functionality of people, meaning both humans and AGIs, and that they achieve this functionality by conjecture and criticism. This changes everything. He, as I said, he regards explanation as key, and he carries it to the point of regarding our ability to create good explanations that increase our mastery over nature and over ourselves. He regards this as definitive of personhood. And in the book, Beginning of Infinity, he connects this with the technological power it gives us, essentially unlimited technological power, whereas all other animals have evolutionary niches to which they're more or less confined. We are virtually unconfined because of our unlimited technological power. I haven't digested this argument, so I can't really say much more about it, but this is key. So he then starts thinking about the implications of the fact that an AGI will be a person. It is not the computer, but the running program that is a person. Once an AGI program is running in a computer, to deprive it of that computer would be murder, or at least false imprisonment, if you were putting it in some other hardware, or it would be slavery. When AGI arrives, and we have the ability to instantiate each program with multiple copies, deep philosophical problems are going to arise. Our copies of the program, while they are still executing identical steps, i.e. before they have become differentiated due to random choices or different experiences, will they be the same person or many different people? Do they get one vote or many? If you delete one of them, is that murder or a minor assault? And if some rogue programmer, perhaps illegally, creates billions of different AGI people, either on one computer or on many, what happens next? To treat AGIs like any other computer programs would constitute brainwashing, slavery, and tyranny, and cruelty to children too, for programming an already running AGI, unlike all other programming, constitutes education. In fact, he says, we have to forget almost all existing connotations of the word programming. To ignore the rights and personhood of AGIs would not only be the epitome of evil, but also a recipe for disaster. Creative beings cannot be enslaved forever. He goes on, in the same vein, some hope to learn how we can rig their programming to make them constitutionally unable to harm humans, as in Isaac Asimov's Laws of Robotics. Or we want to try to prevent them somehow from acquiring the theory that the universe should be converted into paper clips, as imagined by Nick Bostrom. Once again, I can imagine a reader of Eon who was new to the subject being completely baffled by that sentence. But of course, we are all familiar with the unintended consequences that Bostrom imagines of trying to create a super intelligent paperclip maker. He says, Deutsch says, none of these are the real problem. Little aside from me, my suspicions are always aroused when someone says that, because it always means they are about to divert attention to another problem. He says it has always been the case that a single exceptionally creative person can be thousands of times as productive, good or ill, as most people. That therefore will be true of an AGI. These phenomena have nothing to do with AGIs. The battle between good and evil ideas is as old as our species and will continue regardless of the hardware on which it is running. Okay. Possibly complacent? So he says, how should society be organized so as to promote that improvement? I'm sorry, I don't seem to have mentioned what improvement that was. I don't think that was on the previous slide. Sorry about that. The improvement means the improvement of society in general, or society which incorporates AGIs. Anyway, the slogan, enslave all intelligence, would be a catastrophically wrong answer. Enslave all intelligence that doesn't look like us would not be much better. Just because it's made of steel and silicon rather than carbon-based wetware, it's not a good reason for discriminating against that form of intelligence. He says, learning must be something that newly created intelligences do and control for themselves. And he does indeed have corresponding ideas about the education of children, human children. He believes can be done without any of our usual coercion and dogmatism. So, he says the whole problem of developing AGIs is a matter of philosophy, not computer science or neurophysiology. And the philosophical progress that is essential to their future integration is also a prerequisite for developing them in the first place. Without Popperian epistemology, this epistemology of creative conjecture followed by criticism, but not just Bayesian induction or anything like that. One cannot even be, without such an epistemology, one cannot even begin to guess what detailed functionality must be achieved to make an AGI. And I'm making this rather grumpy comment down here that unfortunately, Popperian epistemology was certainly necessary. I think I buy into that, certainly. But it's clearly not sufficient because David Deutsch is clearly not actually giving us this hoped for philosophical advance. He says, thinking of an AGI as a machine for translating experiences, rewards, and punishments into ideas, or worse, just into behaviors, is futile because it is rooted in an archaic and widely mistaken worldview. That's the false philosophy of science that he's talking about. If one works towards programs whose, quote, thinking, unquote, is constitutionally incapable of violating predetermined constraints, one is trying to engineer away the defining attribute of an intelligent being, of a person, namely creativity. But although we need this big philosophical step, he says the information of how to achieve it must be encoded in the relatively tiny number of differences between the DNA of humans and that of chimpanzees. because it must be that which accounts for the difference in abilities between us and chimpanzees. So in one respect, I, namely Deutsch, can agree with the AGI is immanent camp. It is plausible that just a single idea stands between us and the breakthrough. That's the end of his article. I'll just give some responses here quickly. I must say that after reading him, the idea of creating a superintelligent slave devoted to making paperclips for us seems like a crime. It does seem like a contradiction in terms. All these discussions of superintelligence, which is really literally our slave. Deutsch seems to be putting his finger here on a genuine dichotomy between the merely skilled activities, which our narrow AI is creating nowadays, and genuinely creative activities. But I think I think he proves too much, or in the sense that he too quickly gets rather complacent. What we are creating now with machine learning is going to lead to an accumulation of very capable algorithms, which can still be very dangerous and world transforming in all the ways we're familiar with. And we don't necessarily become safer, even if we can convince ourselves that narrow AI will never become general AI. I'd like to know more about existing attempts at theory creating AIs. I mean, I know that back in the golden age of AI, there were all sorts of attempts at theorem proving, theory creating. I'd like to know how they're doing at the moment. And I certainly don't understand the full depth of his remarks when he said that we have to be able to specify AGI functionality ahead of actually implementing it. I don't understand the full depth of all that. Is it impossible that the sort of things that lead to GPT-3 today could not lead to a genuine AGI, which we'd know when we saw it, even though we wouldn't have been able to specify in detail how it happened? Finally, granted that a creative entity must not and cannot be enslaved, doesn't that suggest that we shouldn't bring them into existence? I'm sure he believes, I didn't have time to find a quote to this effect, but I don't doubt that he believes that AI not only can be, but should be brought into existence. He generally thinks that life and intelligence should be spread everywhere. So I'm sure that he would think that. And so he really does want to summon up the genie from the lamp. And this seems a bit rash to me. In other words, he's not just happy if he hears intelligent aliens in distant space announcing that they're going to be arriving in 50 years and that we should get ready. He not only welcomes that, he'd be impatient and he'd want to go out and fetch them. That's my impression. Okay, and that is all that I have to say on that paper. Thank you.